In this video, I'm going to go over how to take a land cover classification like this and turn it into a density map, both as a raster and on a line network. So the first step is to separate whichever land cover classification you're after. So in this case, we're after Russian olive density, so just these pixels. The first step to doing that is just simple reclassify. So what we would do here is input the land cover classification, and in this case it was class, and we're only after Russian olive, so we just change this to a 1 and do the rest as no data. Anyways, you would do all these values, new values as no data. You can just leave all the old values the same. So then once you save that, which I've already done here, you basically end up with this. So all the other land cover classifications have gone to no data, and we have Russian olive. And then the next step is to use the raster to point tool. And we'll input that Russian olive raster, value field doesn't matter, to output point features. So this will just make every single pixel an actual point. Okay, so now that we have that point data set, we're going to do a point density function on it. And you just import the point features, leave that as none. Save and output. Output cell size, we want 1. Circle's fine. We want the radius at 100 for the moving window. Change that to cell. And then hectares for this, I believe that's what we did for the price. And then hit OK for that. Okay, so that has finished. So the next step is to convert this raster into an integer raster so that we can do zonal stats on it. And there's actually a tool, it's just called int, and it's the spatial analyst. And all you have to do is put in that raster and it will change it to integer. So I'm going to save here. Okay, so that's been converted to an integer raster now. So now we need to make sure we have a network to apply that to, and a Thiessen polygons whose IDs match that of the stream. So I grabbed my layers from a RVD project because Jordan wrote the code in a way that keeps the FIDs the same for both the input stream and the output Thiessen polygons. So before I do that, do the zonal stats, I'm just going to make sure that these do line up. So I'm going to go in here, just select the stream and its corresponding Thiessen polygon, open up the attribute table, compare these. So it looks like comparing the Thiessen polygon to the stream network, the FID here for the stream network matches the original FID for the Thiessen Valley. So when we do the zonal stats, I should probably have this on the screen. Anyways, what I was saying, the FID here on the stream network matches the original FID on the Thiessen polygon. So when we do the zonal stats, we have to specify this as the field so that when we get the output table, this original FID can merge back to the FID of the network. that all the attributes will go to. So that's good. We can do zonal stats on that now. And I'm going to do zonal statistics as a table. So I will input the Thiessen Valley as the feature zone. And we want the original FID, not the FID, because that's the one that matches the network. Input the integer raster. Save a place for the output table. And we'll just do all statistic types. So that finished, and it will give us an output table. If I open that, it now has a row ID, but it also has the original FID, and this should correspond with the Thiessen polygons. And I'm just going to double check. I think that one we were looking at was 581. So I'm just going to look at the area. It's 32,997.54. So this should correspond with that. That's the wrong one. That one. Let's see. So this one. So yeah, if you look at the area, it's 32,997.54, which corresponds. So we'll now do a join. We're going to join the original FID with the FID of the stream network. So go over here to join attributes from a table, FID, the table we're loading from is zonal stats, and we're merging with original FID. So now if I open up the attribute table to this, so all these nulls are just areas that don't even have any. Because if we looked at the overall network, most of it goes through Valley that doesn't even have Russian olive, so it's basically all these segments. So just to double check it, I'm going to symbolize it based on the mean. So it looks like it did what we were after, has the highest density in that area. Turn on the rush evolve, and that looks pretty good about what we're after. Picked up this little pocket over here. If I remember correctly, you can mess around with the brakes, or we can mess around with which one of these statistics we symbolize it off of. I think we did mean with the price, and it turned out pretty well. And just to, at this point, solidify it, to solidify that join, you have to export the data. We'll give it a new name too. Just call it Russian olive density. Remove that. Symbology, make sure it's still correct. Oops. Yeah, so it looks like that worked out. And I guess from here, I don't know exactly what our area of interest is, but we can clip it down to whatever like we when we ran the price, we just had it on a main section of the Valley Bottom, where this basically has the whole network with a lot of meaningless data, because I know the Russian olive doesn't even go down here. So I think that does it for that process.